All right, this next unit, we are going to apply everything we've learned in trig. We're going to apply it to triangles. And this is what you did in physics. So this is probably somewhat of a review, especially with SOHCAHTOA here. Okay, we learned the definition of trig functions for an angle in standard position, like this angle right here is theta. We know the sine of theta is y over r, and that the cosine of theta is x over r, and that the tangent of theta is y over x. That's how we learned it. Now, in physics, you might have learned it as SOHCAHTOA, where S stands for sine, O stands for opposite, and H hypotenuse. For the cut, C stands for cosine, A is adjacent, H is hypotenuse. And for tangent, T stands for tangent, O for opposite, and A for adjacent. Now you can also use y over r if you'd like. Y would be the opposite, and r would be your hypotenuse. You can use x over r. X is your adjacent, and r is your hypotenuse. And you can use y over x, where y is your opposite, and x is your adjacent. So here, you can label this one x, this one y, and this one r. Or you can label it adjacent, opposite, hypotenuse. Okay, so the cosine of theta would be x over r, or adjacent over hypotenuse. And the sine of theta would be y over r, or opposite over hypotenuse. The tangent of theta would be opposite over adjacent, or y over x. Okay, so we're going to use, so you can either use SOHCAHTOA, or you can use y and r and x and r and y and x. Okay, we're going to solve for the missing parts. So we've got this angle here. You can put x for cosine, y for sine, right? Or we can call this, since it's next to the angle, it's the adjacent side, and this is the opposite side. That's the side that's opposite from the angle. Like that. Okay, so we're going to find this length, this x, and this y. So we could say cosine of 25 degrees equals x over r, x over 14, or adjacent over 14. Okay, and we could say the sine of 25 degrees equals y over 14. Okay, or if you like using SOHCAHTOA, you know you've got to do the adjacent over the hypotenuse. That's just hypotenuse. Should have made this bigger, shouldn't I? There we go. Okay. And so adjacent over hypotenuse is cosine. Or you can do opposite over hypotenuse, and that's S, or sine. Okay? All right, so then we're going to solve these. So we can multiply both sides by 14. The 14's cancel, and you have x equals 14 cosine of 25 degrees. Okay, so 14 cosine of 25. Whoops, gotta turn it on. Make sure you have to be in degrees. The mode on your calculator has to be in degrees. That's very important. So, we got our mode in degrees. Then we'll do 14 sine 25. And we're going to round sides to 3 decimal places. So this would be 5.917. So side x would be 5.917. Okay, and then we'll do the same thing with y. Multiply both sides by 14. Okay, so we get y equals 14 sine of 25 degrees. So we plug that in. 14 sine 25. Whoops. I did sine last time, didn't I? So sorry. This one is 5.916 or 917. Let's change this. 5.917 for sine. Cosine, sorry about that, 14 cosine of 25 is 12.688. 12.688. Okay, and let's check and make sure it makes sense. The hypotenuse is 14, and it should be the longest side, and it is longer than 12.688 and 5.917. Okay, so these are good. Okay, now, mainly you're going to be doing word problems, okay? All right, so the altimeter of a jet approaching O'Hare Airport in Chicago reads 5,900 feet as it passes directly over the Sears Tower. Okay, so here's the airplane passing directly over the Sears Tower, so this is 5,900 feet. At the same time, the angle of depression from the plane to the end of the runway is 5 degrees. So an angle of depression comes from the horizontal to the angle of depression here, and this is 5 degrees. Now that is the same angle as this one because these are alternate interior angles and they're equal. Or you can subtract 5 degrees from 90 degrees and this would be 85 degrees. So that would make this one 5 degrees because this is 90 here. And they have to add up to 180. Okay, so we know that's 5 degrees. It says, how far is it from the base of the Sears Tower to the end of the runway? So we're trying to find this length right here. We're going to call that length X. We have Y. We have the 5 degrees, and we need X. So Y over X is tangent. Or if you want to think about it this way, this is the opposite. We need the adjacent. TOA would be tangent, opposite over adjacent. So we're going to do tangent of 5 degrees equals 5,900 over X. Okay, we'll multiply both sides by X. X is canceled. Okay, so we have X tangent of 5 degrees equals 5,900. And we want to get X by itself, so we're going to divide by tangent of 5 degrees. And so let's see what X equals. Plug this in. 5,900 divided by tangent 5. 67,437.309. 67,437.309. That would be feet. And that's how far the end of the runway is from the Sears Tower. Okay. At 10 a.m. on April 26, 1988, a building 300 feet high casts a shadow 50 feet long. So here's a building. It's 300 feet high, and it casts a shadow of 50 feet long. That's a little bit long there. You don't want it that long. Okay, what is the angle of elevation of the sun to the nearest degree? Okay, so the angle of elevation, okay, would be this one, which is the same thing as this one. Okay, so we're still trying to find this angle. It's pretty much always this angle that you're trying to find. And we're going to call it theta. Okay, and we have the opposite side over the adjacent side, or we have y over x. Either way, that is tangent. So the tangent of theta equals 300 over 50. Now we're trying to find the angle. When we're trying to find the angle, we got to get rid of that tangent, so we just have theta by itself, so we do the inverse tangent. So the inverse tangent of 300 over 50 is what theta is going to be. So let's do second tangent, 300 divided by 50. So theta equals, and let's round it to the nearest degree, so it would be 81 degrees. That's 81 degrees. Okay, number 4. At a point 125 feet from the base of the building, the angle of elevation to the third floor is 22 degrees. So this is 125 feet. The angle of elevation right here is 22 degrees, and this is the third floor. Okay, then it says the 10th floor is 53 degrees, so all the way to here is 53 degrees, and this is your 10th floor. How much higher is the 10th floor than the third floor? Okay, so let's find how high the third floor is first. That would be this part right here. There's the right angle. We'll call it Y. So we're going to have, and we have the adjacent side or the X side. So we're going to have the sine, I'm sorry, not the sine. Opposite over adjacent would be tangent, or Y over X would be tangent of 22 degrees. Can you come back? Or you can just not clean it today, because I'm working on this. Okay?
I come back tomorrow.
That's fine.
Yeah.
So tangent of 22 degrees equals the opposite, or the Y over the X. Okay, then we're going to get rid of that 125 on the bottom, so we multiply both sides by 125. And those cancel. So Y equals 125 tangent of 22 degrees. So plug that in the calculator. 125 tangent 22. The 50.503. So Y equals 50.503. That would be the distance to the third floor. Okay, now we're going to find the distance to the 10th floor. And we know the angle for the 10th floor is 53 degrees. So we're looking at this big triangle. Okay, so we'll call this whole distance right here Y. And we have the opposite over the adjacent, or the Y over the X, same thing. Except now we're going to have tangent of 53 degrees instead of 22 equals Y over 125. Multiply both sides by 125. So Y equals 125 tangent of 53 degrees. So it'd be 120, oh, let's work this out on the calculator. 125 tangent of 153. No. How about just 53? Start over. 125 tangent of 53. 165.881. Okay, now it says how much higher is the 10th floor than the third floor? And the 10th floor is 165.881. So we're going to subtract 165.881 minus 50.503. So minus 50.503. Get 115.378. Feet? Is this feet? Yes. Okay. So that would be how much higher the 10th floor is than the third floor. Okay, now on your assignment sheet, you have to use this one. We're going to do numbers 1 through 9. Okay, and let me show you this one. It's going to set this one up for you. Okay, you've got the Grand Canyon problem. From a point on the north rim of the Grand Canyon, a surveyor measures an angle of depression of 1 degree to a point on the south rim. Okay, so this is how this looks. Here you've got the Grand Canyon. The north rim is taller than the south rim. Okay, so this is your north rim. This is your south rim. Okay, and here's your triangle. Okay, and the question is, well, first of all, from an aerial photograph, he determines that the horizontal distance, which would be right here between the 2 points, is 10 miles. So this is 10 miles. And it says, how many feet is the south rim below the north rim? So we're looking for this right here, and that would be y, and this would be x. So we're going to use tangent, and it gives us the angle of depression, which is 1 degree. Okay, but since we want it in feet, let's change 10 miles to feet. 1 mile is 5,280, so we're just going to multiply by 10, so that would be 52,800 feet. Okay, so we're going to use that instead of the miles. So you would set this up as a tangent. You'd say the tangent of 1 degree equals y over 52,800 feet. Okay, and then you want to solve for y. I'm going to get y by itself. And y would be the difference, how much taller the north rim is from the south rim. So find what y is, and that will be your answer on that one. Okay, the other one I need to do for you is I need to do the picture on number 4B, because the picture on number 4B is totally wrong. Okay, so let's mark this one out. Okay, and from the top of a building 150 feet high, so we're going to draw that building. That's 150 feet high. Okay, and we can do little windows, show it's a building. Okay, from the top of a building 150 feet high, the angles of elevation and depression. So one is going up, one is coming down. Okay, this would be your elevation. And that angle is 22 degrees. Okay, and then the angle of depression would be down here. That would be 36 degrees. Okay, and it's to the top. It says the angles of elevation and depression of the top and bottom of another building. So here's the other building. It's taller. You know it's taller because it has an angle of elevation right there. Okay, so there's another building. All right, so you have this triangle, and then you have this triangle here. Okay, and you know that's 150 feet high, and so you can find out this distance going across, because it wants to know what are the height and distance of the second building. So to find the distance of the second building from the first building, you would do y over x, or opposite over adjacent, and that is tangent. Okay, up here, it wants to know the height of this building. Well, you know that to here, it's 150 feet, because this one's 150 feet. So if we can find this distance, we can add it to 150 feet. Okay, and once you find what this distance is, then you will use it right here, and we'll have y over x, or tangent again, tangent of 22 equal y over whatever you got for this distance from this one. So you're going to do the big triangle first, and then the little triangle. Okay, and that is it. You're doing 1 through 9. If you have any other, go through all this. If you have any other questions, try it yourself. If you have questions, you can come see me.